Hi everybody, thanks for coming to my talk about how to extend Webpack with your own plugins and loaders. My name is Viktor Razumov. I'm a Russian developer living in Munich, Germany. I work for a small startup that automates customer service with AI chatbots. And just a couple of funny facts about me. Before doing so, I used to work as a business analyst in Dubai. I sold wine packaging in Tbilisi, Georgia. I had a chance to work as a business analyst in Iraq on an oil field. So yeah, the guy in the center in a flak jacket is me in the body armor. So yeah, real body armor and real ATV, armored vehicle. Yeah, but apart from that, I actually enjoy coding and I earn living by coding, so you can forget about these facts and we can keep on moving. So why we are here, I guess every front-end developer, or at least most of front-end developers and front-end teams today use Webpack, but I doubt that even the ones who master the craft of writing proper config files for Webpack understand the mechanics under the hood. So this is one of the reasons, and I think, do you hear me well? Okay, sorry. So another reason is that Webpack is quite a cool tool to add some more functionality that is not related only to transpiling or bundling. So this is what we're going to do today. First of all, we will learn how Webpack works. Second and third, we will write the main two entities to extend its functionality that are loaders and plugins. So first things first, how does it work? You write a proper config file. You spend 2 or 3 years and I guess a couple of your front-end projects to write a proper config file. Finally, it works out and you get one, or if you're like good enough, you get multiple bundles of files. But I guess like you do not know what happens under the hood. If you know, you can just go to the another talk. This is fine. But what I also want to show you is how actually the workflow happens under the hood. So if anybody has been to Sean Larkin's Amsterdam talk this February, yeah, you also know the stuff, but I wanted to show you some pictures, but my camera got broken, so I need to draw the workflow once again for you. So in the heart of Webpack, there is a library called Tappable. You can find it in Webpack repository in GitHub. This is a small library that basically allows you to attach some pieces of work together and actually attach some hooks and custom functionality at any point of time in this in these pieces of job. So you just need to know about that. You can learn more by going to GitHub and looking at it. But how actually Webpack works? When you start building, a compiler starts and initiates everything. It gets basically the options that you pass to Webpack through a config file, and then it creates compilation. What has Tapeable with this one is that they're based on Tapeable, and even in the very beginning at compiler stage or compilation stage, you can already attach your plugins and extend functionality if you need it. Compilation creates module factory, actually multiple module factories, but we will use the abstract one or normal module factory that produces modules after resolving them from your file system. If this module, for example, is JSX or CSS or whatever, and it requires a specific loader, it goes through a loader, and surprise, the output is module again. This module goes to a parser, really big important part of Webpack that parses your module and outputs abstract syntax tree, comments, and some other useful data. And again, after that, you get a module, but with dependencies. So whenever you call import or require in your JavaScript module, actually Webpack registers dependencies that go again to the module factory and do these things recurrently. After all these circles of the Webpack workflow, you get a bundle graph that then goes to JavaScript generator that we will not talk about today, but briefly it just gets your module source code, all of its dependencies, and produces bundles. But today we will talk about loaders and plugins for parsers, because loaders, you can find lots of information about writing loaders in the web, but most probably you will find nothing about writing plugins for parser. Even on the webpack documentation side, you will find description of some hooks for parser plugins, but most of them will be not described anymore. You will just see 3 commas or to do. So there is quite a big room for improving and for contributing to webpack. Another thing is that it sounds pretty easy that you can, this is basic workflow of webpack, and you can just inject anything you want in any part of the flow and write your own plugin. But the problem is, if you try searching plugins in webpack source code, you will see that actually there are tens of non-documented plugins that do something. Some of them you know, like replacement plugin or import plugin or maybe provide plugin, but most of them are not documented, and you will just need to go through the source code to understand what's going on there. So these are the main problems you face when you try to extend functionality with Webpack, but this is fine. I'll show you the perfect workflow I found out when doing this. So before we start, 2 pro tips. The first one is if you're using, for example, VS Code or any other IDE that supports inspecting or debugging, or you use any other inspector like Chrome DevTools, you can attach this inspector to Webpack runtime. And actually, this will allow you to add breakpoints and watchers for your variables or what you write in your loaders and plugins. This is super helpful when you write plugins especially. But pay attention that you attach your inspector to Webpack bin Webpack. There is also lib folder. It will not work. You need to attach to bin. Unfortunately, most probably you will not be able to break in Webpack. I mean, I failed doing so. Maybe there are some other tricks, but I didn't have enough time to discover this. I also just opened the Webpack folder in your project as a separate workspace, because you will do lots of global searches in Webpack to understand how plugins work. So we'll write a loader right now. This is Leo Tolstoy, famous Russian author. What has he in common with JavaScript? I would say nothing, but I came up with my Cyrillic subtype of JavaScript. I know this is kind of blurry, but I guess some people of you know Cyrillic. And this is just JavaScript written in Cyrillic. This is kind of stupid and not useful at all, but this is what you actually can do with loaders. So if you can see, this is just import something from a module. This is const service that is basically an object with some methods inside. This is a function. I have console soобщить that is actually console log. And then I call f1 with данные, that is data. So yeah, this is kind of stupid, but this is a good story to show you how loaders work. So loader is basically a function that takes your source code and surprise outputs source code. You can also make use of Webpack utility functions that allow you to read options from the config file and validate them against JSON schema, but we will not dive deep into that because it's super easy and you can understand that easily. But how does my Tolstoy loader works? First of all, we don't care about if string literals are in Cyrillic. I mean, we need to preserve them no matter which language are they. So first of all, we need to extract string literals. And as you can see, I have console soобщить FrontCon. And after running this function, well, I will have still console soобщить, but it will be replaced with some nonsense like exclamation marks and string 12. But I will also get literals map to revert the separation once we are done with transpiling. The next step will be transpiling the keywords like constanta making const, funkция making function, also easy to understand. Then we just take everything that's left and transliterate it. So we had const for, and now we have const foo. And the final step is bring out string literals back. So we had this nonsense exclamation mark string 12, and now we have back FrontCon. And you may probably not believe that this Cyrillic stuff works, but I will show you that it actually works. So here is my Lev Nikolaevich files. You see that I'm not even using JS. I'm using LN file extension, and I can afford it myself because I have my Tolstoy loader. So this is my file that I have just shown you. Well, this is my Tolstoy loader, and you see I have breakpoints in each step, and I will just launch it, and we'll have a look how it works. So when it breaks at the first step, and I have a look at source, you see everything is Cyrillic. You just see part of it, but it's in Cyrillic. I jump to the next step, and if you have a look, you see that I have replaced all string literals, except from, template literals. Yeah, I do not support them yet in my version of Tolstoy. Next version we'll get it. But the rest is replaced with some nonsense. Next step is just transliterate everything. Transpile keywords. Now we have let, we have console log, we have function, but the rest is still in Cyrillic. Now we click the final step, pre-final. It's transliterated, but we still have nonsense. Now you see we have shtuka service.udalit, but it's in Latin. It's pure JavaScript, believe me. And now bring back my string literals and get my lovely JavaScript. So yeah, I can hear a round of applause for that, for making Tolstoy work. Actually, I have some even other modules imported. I will just not show them. I will finish it running, and to prove you that it works, I will run. Okay, it's Cyrillic. So you see the stuff has been transpiled to pure JavaScript. It works. So all good with loaders, and the documentation is pretty much good. So, but what's wrong with webpack? That if you try to write your plugins, doing some stuff with your source code, as I said, you will find no documentation at all. And the quality of documentation you find is usually super low. So you need to take a big shovel and just go and dig into webpack source code. This is what we're gonna do right now. But why would we need this? Imagine a situation like this. I have a parent function defined like parent that takes 2 arguments like parg1, parg2, and it calls the child function with 3 other arguments. Pretty easy. And then I just call parent function with pp1 and pp2 as arguments. What I want it to do is that my child function implicitly gets access to what parent function got as arguments. JavaScript doesn't allow you to do so out of the box. You need to do some tricks. So I don't want to change my source code, and the real situation that I got into in my experience was that we had lots of this kind of stuff that we had to pass some metadata or matrix data or params as arguments, and our developers were forgetting about this. We had really big code base, and so we were thinking that we need to do, and we had a compile time, a compile stage through Webpack. So we were thinking like, okay, to be on the safer side, we just will add this implicit functionality into Webpack. So this is my child function definition. You see, I still have arg1, arg2, arg3, but when I console log parent context, some parent context, it should print out parg1, pp1, parg2, pp2. What is parent context? How does it get defined? It's just something like parent context.cat. Some experienced developers could say that, yeah, then you can just take Webpack and replace every call to parent context.get to some arguments. But what I also don't want to do is to get blamed by linters, because ESLint or TSLint, and I guess all of you are using linters today, will blame you for using undefined variables like parent context. What is this? So, and I want my functionality to be completely isolated inside my plugin. So I don't want to add any or to customize my linters features. So the last step would be to actually define parent context and require non-existing package parent context. I know that there could be some collisions, but most probably not. So how will my plugin actually work? The workflow of my plugin is, first of all, I catch every require to parent context I intercept it, and I enable my plugin and remember where does it go. So that parent context only got require of parent context. Next thing is wrap and provide parent params to a child call. So I just grab prarg1, prarg2, wrap them in an object, and pass them as last argument of child call. But to be on the safer side, I actually add a bunch of undefined stuff before that, because at compile time we are not sure if this takes 2 or 3 parameters, as you remember from Rachel's talk today, that JavaScript is fine with everything. Like you just give it, if you're not using TypeScript, yeah, or flow, any static type and stuff. And the last step is every call to parent context dot whatever, I just put a get for making more sense, but I don't care about any other call. Just replace it with arguments last. Just take the last argument from child and give it and put it there into parent context. One more boring thing about parsers. Let's have a look how actually parser works inside Webpack. As you remember, it takes source code and it outputs source code plus dependencies, but we need to know the trick about parser, or if you need to replace your code with something else, you also need to register a dependency. This doesn't seem straightforward from the first glance, but this is how Webpack works. So either actual call to import or require, or if you need to replace some code, you register dependencies. So when we start a parser, it calls acorn.js library. This is another library written in JavaScript, basically JavaScript parser written in JavaScript. So it takes your JavaScript and gives you abstract syntax tree. What is abstract syntax tree? I guess every one of you knows. Okay, if you do not know, please show me your hand. Okay, then I need to explain it a bit. So you know that your source code is just a bunch of characters, of symbols, and then it forms like some syntax, right? Some lexems. So when you want to work with your source code, you give it to a parser, and parser actually reads your source code and outputs it in an object notation. Like if you say function name, and some parameters, you will have an output like node, function expression, function name is this, parameters are that. This is abstract syntax tree. And you also get comments out of acorn.js. Every comment you mention in your source code will be output from acorn. Then you can already attach your plugin. Webpack allows you to do so. We will not be going through pre-work and work phases of parser, just for the reference so that you know this is how the whole parser workflow works. But what we're gonna do today, we will just put our plugin right here, right when you get AST in the very beginning. Why? Because it will allow you to actually inject more plugins in pre-work and work stages. Pre-work and work stages, you can just go through plugin source code and see what it does, but basically it works with variable declaration, function expressions that you found in your source code. And actually you can even skip them by returning some truthy value from this plugin. It's not required because it will bring you lots of problems with imports or requires, but you can still skip it if you need. So enough boring parts, let's go to our live coding stuff. One more time, have a look at our JS file that needs this parent context be injected. And let's start running the code for the plugin. Yeah, when you write plugin for Webpack, this is pretty much lots of boilerplate, because as you remember, if you need to reach parser object, you actually need to go through the whole workflow that we have gone through, like compiler, hooks, compilation, tap. This is where you inject one like plugin. Then you get normal module factory, hooks, parser, inject. Then you get parser, hooks, program. Program is actually the stage when your AST is already here, and you inject and you get AST. So what we are doing first is we are ignoring node modules. We do not want to apply this stuff to node modules. We just don't care. We want to apply this stuff to our source code. Then here you see we already got broken here and we got AST. So I will show you what AST is. You see it has some metadata, but basically we care about body. What is body? Body of our index.js is variable declarations, function declarations, expression statements. So basically it has some source code and some stuff that describes your source code or parts of your source code. The next step is that we take this array of objects and just walk this through. Just go through each of them, iterate through each of them, and apply some stuff. So depending if this child node is function declaration, we call one handler. If it is variable declaration, we go to another one. If it's expression statement, we go to the third one. There are way more types, but we don't care for this exact plugin. So let's keep on going. So this is our first part. You remember the interception of calling require parent context. You see that, let me show you that actually this is variable walker. This is walk variable declaration where we actually got broken. And what we see here is that our callee is require and its first argument is parent context. So what we are doing here, we're enabling our plugin and we're remembering the variable name that got this require. So this is the first step of our workflow. Next step is for every function call, we extract parameters. You see, you remember our child call that was arg1, arg2, arg3. So we just extract it and pass to the function that walks blocks, that again iterates through each declaration in your source code. But now it has params. So the next step would be, again, variable declaration, but actually now it found parent context, you remember? Whenever we have parent context, what we need to do? We need to replace it with our last argument if we have our plugin enabled. So what we will have, you remember we had const parent context equals parent context.get, but we will replace it with this stuff. Parent context equals, if we have the last argument and the last argument is parent context, just use it. And this was when we actually register a dependency that I was talking about. We're saying kind is what we take from the description of your that we receive from the AST, that we'll say const. Variable ID is parent context, and then we just write plain string arguments lengths and argument take last argument. So the next step will be, again, walk the function. Now we are in the parent context, in the parent function, and now what we need to do, wrap parent context and provide it to the child call. So if you have a look, our parameters that we get now from parent, they're parg1 and parg2, the arguments. What the output that we need will be the following. Lots of undefined, as I told you, to be on the safer side, but this is stupid. I mean, you can definitely, having this AST data, improve the flow, but just for simplicity, I kept it like this. And then provide your parent context wrapped in an object. This is basically it. This is the full functionality of the plugin. So we, again, register new dependency, and we actually replacing our child call that was just A, B, C, D, E, F, G, H, I to another one, but with the parent context. So this is it. This is how a plugin works. And it doesn't look that difficult to manage this one. So if I run now the output, you will see my child function will actually get the parent context, as I promised you. So yeah, this is how the plugin works. And what are the key takeaways of our of this talk today? Webpack is not only about bundling and transpiling stuff, but it's also quite a powerful tool to extend your functionality or even bring functionality that you cannot write in the code. So some kind of meta functionality. There are almost no documents about this, so you can dig into the source code, that's good, you can learn a lot, and you can contribute. Webpack team is quite nice, and they love contributors. And they also, I guess, claim that they're the project that has the biggest number of contributors, but we know the reason. And you can write your own Babel or TypeScript compilator or Tolstoy version 2 or whatever. So yeah, just I want you to be encouraged to do that, and yeah, go for it. Thank you. And one more thing, bonus. I want to thank organizers of FrontCon. They allowed me to promote the conference that I'm organizing in Munich. It will be on 27th of April, and for all of you, we have a discount of 10%, so you can use the code. And please come to Munich. It's already very nice right now, but in the end of April, it will be super green. You will have lots of flowers blooming. You will have lots of nice German beer, potatoes, sausages, and cabbage. Yeah. So, guys, you're more than welcome, and thank you.
Questions? By the way, if you want to, you can leave the do you want to promote your Twitter or you want to promote the conference? It's up to you.
Okay, it was enough for the conference. Now I can promote my Twitter. I also need at least 12 people.
12?
Yeah, no, I'm planning for 20, but 12 will be also fine.
How high are you now? Like how many do you know? I mean, you're a big shot on Twitter, so it's not as big deal for you. But anyway, questions. We have time for questions.
Okay,
wow.
I can say that my presentation was so clear.
Yeah, it was.
That everyone can just rewrite this plugin like from the head.
What's the reason why webpack has the biggest amount of contributors? You said that everybody knows. I don't know.
Because there is no documentation. I guess they're happy that even if you bring one line of documentation to the code, like to the docs, they will say, yeah, sure, just be contributor. Oh, we have a question. This sir in black blazer.
How many words does this Tolstoy understand?
I'm sorry?
From Russian Cyrillic names, how many words does it can it translate?
You mean, yeah, actually this was one of the steps. That when we had Cyrillic definitions or declarations, one of the steps was to transliterate. So we just have a transliteration map that, for example, symbol your, character your, that is existing only in Russian, I guess, will be transliterated to YO in Latin.
And if it intercepts some reserved words from JavaScript, it
yes. So just one more time, we extract string literals because we don't want even Cyrillic string literals to be translated or whatever. We need to preserve them as they are. Second step is what we are doing is we transpile keywords. So constanta will become const, переменная will become let or var, depending on the version of Tolstoy. And then we transliterate all the rest. So if you had declarations saying Shtuka, it will be item, but now I'm joking, it will be Shtuka, but transliterated. So, but you can do anything. I mean, you can add wherever you want. You can extend the list of keywords, or you can add some translation stuff. But basically, this is how it works. Yeah.
Thank you.
Okay, thank you for presentation. I have a question. Won't it be easier to make plugin not for Webpack but for Babel? So it will be like new preset Tolstoy.
Yeah, actually this is what I found in the web when I was looking for some documentation, that writing plugins for Babel is way easier. First of all, in terms of like how do you attach your extra functionality to Babel runtime. Second, they have better documentation, but it's an easy way, right? I will not be talking here today if I didn't do that. I mean, if I chose Babel, because everyone chooses Babel. So. Yeah, I mean, it could be easier. Yeah, but that's just an example, right? But yeah, thank you for the question, actually. It's a good point. Any other questions?
Is there a question you would want them to ask you? This is a cop-out. We have the time, so.
Yeah, usually when I tell about Iraq, people ask, how was it in Iraq? Or when I tell people, like, they used to live in Dubai, they ask, oh, especially girls saying that, do I need to wear burqa in the street, or do they kill women with stones? So, yeah, the answers are no, they are not killing women with stones. You do not need any burqa, neither women nor men. And in Iraq, it was fine. So.
How is it with front-end market in Iraq?
Do they pay the top salaries?
That's a tricky question. I mean, why I can actually I didn't see actual Iraq, because what I have seen from Iraq was window of my armored vehicle, and also concrete walls of my oil and gas camp. So yeah, actually I was just working for this oil field. But I can say that, I mean, from my colleagues that were locals, I guess they're just using Facebook for everything. Like, they're not building any websites or whatever. They're just promoting their business there. And the same actually applies to Georgia. I had a chance to live in Georgia for a while and do some business there. And you don't need any websites there. It will not work. You need Facebook. Like, Facebook doesn't pay me actually for saying so. But
hello.
Hi.
I want to ask you about where you showed where you talked about your real life example, so that where you had to put some metadata in to pass down. Don't you think doing it this way with webpack plugins like hides some functionality behind, like, so onboarding a new developer might be a little bit difficult or something like that?
Yeah, this is actually a really good question, because we still haven't applied this functionality in real life. And what we have done is we have lots of discussions, and one of the points was that bringing implicit functionality to your code base is not always good. And some folks can forget about this and maybe cause some collisions if you do not protect, if you not choose the defensive side and protect yourself from any type of problems that could happen. And you still can get into the problem by not forecasting everything. So yeah, but we have quite a big code base, and actually even going through all the calls of these methods where we need to put metadata will be really expensive, and we still will be on the side that a new programmer comes, he still gets onboarding, but he just forgets about adding this metadata. And yeah, you can add maybe lint rules, like custom rules or whatever, saying that you need to add metadata here, do not forget doing so. And we actually have now, like, if you call this method that actually writes some versioning data into the database, we log in an error in our backtracking system, or we also log in an error in your local environment saying that you haven't passed trace ID and other matter params. Please consider doing so in all your next calls. But sometimes you have to disable it because you bring some new functionality in tight schedule, and for example, you're importing some data, and this error gets called like 1,000 times, and it just becomes some white noise no one sees. So yeah, it's kind of, you need to balance it. You need to introduce people to that if you decided to do so. Yeah, but thank you.
Okay, so the next question. How are you looking on Webpack comparing to Parcel?
Honestly, I do not have any experience with Parcel, so I'm looking for, I think Yanis will
give there's a lightning talk
about Parcel. So, and it's really bold statement saying that, is it your new bundler or whatever? So yeah, I will learn something. So I don't have any experience with Parcel. Any other questions? No, but okay. Thank you guys, and see you somewhere there.